So far in these lessons of lift, we have considered only two-dimensional airflow, and a sound understanding of this is the foundation for a full appreciation of the actual pattern of the airflow around an aircraft. Even small changes of air pressure will modify the airstream direction by inducing flow towards any region of the low pressure. This three-dimensional airflow can modify the angle of attack, creating an effective angle of attack. It may increase the drag and alter the stalling characteristics, and can even influence the control and stability of the aircraft. From now on, instead of just airfoil section, we will considering the entire wing and the pressurizers. To the next few lessons, you will need to understand and be familiar with the terminologies associated with the wing. The wing area is planned surface area of wing and has a symbol S for a surface. It's deemed to include any part of the wing curved by engineer cells and the part of the fuselage in the line with the wing, since the pressure pattern carries over these areas, allowing them to be legitimately considered as a part of the entire wing. The wingspan lowercase b is the distance from the wingtip to wingtip, usually none quoted in meters. The chord is which is the distance from the leading edge to the trailing edge, and the average called lowercase c is the geometrical average. So the product of span and average chord is the wing area, and the aspect ratio or AR is the proportion of a span in the average chord, that is B over C. And if the planform is curved, for example like the split fire's elliptical wing, an alternative way for determining the aspect ratio is the span squared over an area. This assumes, of course, that you have a figure for wing area. The aspect ratio of the wing determines the aerodynamic characteristics and the structural weight. For example, a wing area of 100 square meters could be arranged in a high aspect ratio here as a 51, or a low aspect ratio of say 3 typical AR, varying from this value for the modern compact aircraft to 12. For higher jet speed transport is to 35, and for high performance sailplane continuing with this. We have the root chord, its wing center line denoted by CR, and we have the wing tip that is denoted by CT. The ratio between them is the taper ratio. The taper ratio will affect the weight of the wing and thus the lift.